Lesson 3, topic theoretical and experimental probability. Learning target, I can find the theoretical and experimental probability for given situations. First off, some vocab. Theoretical probability is what is expected to happen based on mathematics. So this is what we were working on last class. We have the probability of the event happening, and then on the top would be the number of favorable outcomes, or what we want to happen. So like if it was the probability of rolling a 5, then that favorable outcome would be rolling a 5. And then the total number of possible outcomes. So let's give that an example. We've got a spinner here. The total number of possible outcomes would be the number of spaces that the spinner could land on. The number of spaces the spinner could land on, we have 6 total spaces. So that bottom number would always be 6, because that's the number of possible outcomes. Then the top number comes from what our probability we're looking for. So the first one we have is the probability of 4. So what's the probability of spinning a 4? We only have one space that is a 4, so our probability would be 1 over 6. One favorable outcome over 6 total possible outcomes. And then what would be the probability of spinning an even number? Remember, even numbers are numbers that are divisible by 2. So if we started with 2 and then counted by 2, it would be 2, 4, 6, 8, and so on. Odd numbers are the opposites of the even numbers. So any number that's not even is going to be odd. So if we start at 1 and count by 2, we have 1, 3, 5, 7, and so forth. So we just have to count up the number of even numbers we have on the spinner. We have 1 even number, 2 even number, 3 even numbers. So we'd have 3 over 6, which reduces to 1/2. So that's theoretical probability. Now, experimental probability is found by repeating an experiment and observing the outcomes. So you actually get to experiment. So probability of the event is the number of times the event occurs over the total number of trials. So we're actually going to do a trial here. We are going to actually spin the spinner. We're going to spin it 5 times and we're going to record the results. So spin number 1, we rolled a 4. So over here on my table, I'm going to put, I rolled a 4 for the first one. Then I rolled a 3. Then I rolled a 5. Then I rolled another 5. And then I rolled another 4. So, since we completed this experiment 5 times, the total number of trials is going to be 5. Our denominator is going to be 5 because we did this 5 times. So the probability of spinning a 4 based off of this is I spun a 4 1 time, I spun a 4 2 times, so it would be 2 over 5. And then the probability of spinning an even number, well, that's the same probability of spinning a 4 because 4 was the only even number that I spun. So it would still be 2 over 5. So you can see the probabilities of the experiment versus the theoretical probabilities are not the same. So let's do one more example. We're going to do dice rolling. So we're going to find the probability for rolling 1 dice, and we're going to do the theoretical probability, and then we're going to do the experimental probability. So reminder, theoretical probability is based on what's expected to happen. So the denominator is going to be the total number of possible outcomes. So if we spin 1 dice, we have 6 total possible outcomes because there are 6 numbers on the dice, 1 through 6. So I know my denominator for theoretical probability is going to be that 6. Then we have to figure out the number of favorable outcomes. So for this first one, it's the probability of rolling a 5. Well, there's only 1 5 per dice, so it would be 1 out of 6. Probability of spinning an even number or rolling an even number. Well, again, those even numbers would be 2, 4, and 6. So there are 3 even numbers on my dice. So it would be 3 over 6, which equals 1/2. The next example, probability of spinning an odd number. Well, we'd have 1, 3, and 5. So again, we'd have 3 out of 6, which reduces to 1/2. And then the probability of spinning a number greater than 2. Well, the numbers greater than 2 on a dice would be 3, 4, 5, and 6. So that would be 4 out of 6, which reduces to 2 out of 3. All right, so now we're going to do the experimental probability. I did the experiment and I recorded my outcomes in this frequency table. I did the experiment 10 times. So reminder, experimental probability, you put the total number of trials on the bottom. So that means our denominator is going to be 10 because I did the experiment 10 times. And now we just have to use the table to tell us how many times that event occurred. So the probability of rolling a 5, how many times did I roll a 5? Well, I rolled it 0 times. So 0 out of 10 or just 0. Probability of an even number. So we have to count up each time I spun an even number, or rolled an even number, excuse me. So 2, 4, and 6 are my even numbers. So I would do 0 plus 4 plus 3, and I would get 7. So 7 out of 10, and we can't reduce that. The probability of rolling an odd number. So again, we would look at our odd numbers in the table. So our odd numbers are 2, 3, and 5. So we'd add up those frequencies. So 2 plus 1 plus 0, which is 3. So the probability of spinning an odd number is 3 out of 10. And probability of a number greater than 2. So we'd have to add up all these probabilities here. So 1 plus 4 plus 3, which is 8 over 10, which can reduce to 4 over 5. So that is how you find theoretical and experimental probability. You can go ahead and move into your practice.